hour, quite lengthy, 1 hour, is to share with you on the virtual augmented reality, the technology. And we use technology to enhance learning. So what is some of the idea development and the practice we have been busy in the last several years. And today I think I will mostly focus on the VARTeL for manufacturing. Okay, I'm Professor Chai from School of Mechanical and Aerospace Engineering. Let's see. Okay, some background information. I always start from this picture. Actually, one of the legendary figure, Professor Alan Sutherland. He visited us 2016, and he's the best person in the world today, talking virtual reality. Okay, during his visit, actually, we have a lot of discussions. This is the picture. Inside the picture, there is another picture. The same gentleman, 50 years ago in MIT, in Boston, in Harvard, invented the world's first head-mounted display, HMD. Okay, so today, actually, very much often we're referring to this, I think a lot of vehicles. Switch off. Okay, thank you. The HMD. That time, actually, not like today. We have Oculus, we have HoloLens, 250 gram, half kgs. But that time the HMD is very, very heavy, so he need to use a supporting structure hold this HMD head-mounted display. And that time, actually, there is no such thing virtual reality. He used a term called Alice Wonderland. You know, everybody knows Alice Wonderland. So virtual reality during that time actually is very much a earlier stage kind of development. And he used a term called automated display to referring this head-mounted display. And why he wanted to have VR? Reason being, actually, he did his PhD in MIT. His PhD is talking about sketchpad. Today, everybody knows CAD, right? Computer-aided design. He's the very first person come up with the idea, design a program so that our manual drawing become computerized. So he is the very first people come up with a mathematical representation. And once the math is there, people ask, can you show me? Therefore, by the way, he invented the second area called computer graphics. Okay, so computer graphics, computer-aided design, even virtual reality, all because of this gentleman, starting from his PhD work. Okay, but today, if we look at today's, because of Sketchpad, then we have, by the way, he invented HMD. Why? He can see the three-dimensional structure. At the same time, he can use some way to manipulate, to interact, to modify the shape. All right. And today we know CAD, CG, VR, all big industry. And under CAD, we have computer-aided manufacturing. It's also very big, particularly for 3D printing, because of CAD. So printing become something digitalized. And I will show next slide the size of the industry. According to this company Research and Markets, they have this 2020, the year 2020, CG, computer graphics, CAD, CAM, 3D printing, VR. Okay, smallest one is CAM. It's about 2.69 billion. Okay, 2 years ago, and virtual reality second is about 4.42 billion. The size of the industry, and CAD 9.46 billion, and the next one is the 3D printing 16 billion, and surprisingly, computer graphics is the largest. It's 354 billions. Why? Okay, we watch movie, we play a lot of games, so the CG industry is very large. Look at the 2020. But in 10 years' time, you can see in 10 years' time, CG will be reaching 642 billion. And the annual compound annual growth rate is 5.2. It's quite good, I would say, for a large scale kind of industry, 4.2 annual growth. And CAD, the growth is even better. By 2030s, we have 17 billion, okay, and CAGR is 6.4 percentage, okay, and the CAM, the growth rate is even better, is 8.4, reaching 6.2 billion by 2030, okay. The next industry, 3D printings, will become quite substantially grow into 76 billion. Growing rate is 20.8. Okay, look at the virtual realities. By 2030s, it will be about 20 billion. Okay, and the annual growth rate is 15 percentage. Why I mention this? Actually, the reason why we need to do something, okay, accordingly. Firstly, we are in the industry 4.0 eras, and you will see a lot of industry is going to require VR, AR, robotics, artificial intelligence. So this kinds of trend require the educational industry to do kinds of change. Okay, and there are challenges. Today, manufacturing education in NTUs very much still the conventional, traditional kinds of things. Although we have made efforts to inject the Industry 4.0 element, but globally, I would say still we are using the Industry 2.0, the mass production approach for manufacturing educations. And we actually need to really do something innovation in order to help our educational sector produce our students better prepare for the Industry 4.0 eras. Okay, so here is the background. And next, what NTU is doing. So NTU approach, in fact, you see this direction from e-learning around 2000. We start to push e-learnings. So many professors are encouraged to do e-learnings by convert the conventional overhead projector slides into something PPT. Not that easy. Okay, suddenly everybody start doing that. Why? Because SARS time. So we have no choice but to convert the lecture into online. So actually, because of SARS, and we have a very good progress in the e-learning things. About 15 years back, we start talking about a program called Blue Ribbon Program. Basically, it's to revamp the curriculum, the traditional curriculum, by injecting the Industry 4.0 element. Almost each subject, every lectures are asked, can you think about how to change your curriculum to inject anything related to Industry 4.0? So it's a Blue Ribbon Program across the whole university. Okay, and 5-6 years back, we start doing something called technology-enhanced learning. Think about how we can use technology to help our students to better understand the various of different subjects. Okay, and the last one, virtual augmented reality. I will detail a little bit in the next slides. Okay, so this is directions, and we have tried, and the platform of e-learning. Actually, we have always stick on the blackboard. Early days we used blackboard, the company, the brand from a commercial product, and then we do some customizations. So students actually, some of them do not know blackboard. Rather, we use the term called adventures. And today we have third versions of the blackboard. Still the same background, backbone, except that the content, the customization is very much NTU kind of thing. So we call it NTU Learn. And those are the platform. We have all the lecture notes saved there. Students can visit the blackboard. But how to create the contents? Actually, we going through 3 stages. The first one, each and everyone use a laptop, then you do a video recordings. In my case, my office actually is not soundproof. Somebody knock my door, then your record video have this noise, and somebody call you, then all those kinds of issues somehow is in the lecture kinds of digital version. You have such problems. So after a while, 5, 6 years later, the university decided each classroom we have a camera, something like this. When you start your lectures, then the system automatically doing video recording. The advantage is actually you have more interactions. Somebody asks questions, then we start talking to each other, right? Interactive kinds of things are much better in this second version. But the problem is because a student can come late, leave earlier, so you always see the video always some kinds of in and out, in and out. And quite recently, 4 or 5 years back, we start doing the technology-enhanced learning. So technology like a blue screen, green screen are used like in studio, like those Channel News Asia kinds of news reports. Okay, so myself, I try a few ways. The first one is using the so-called interactive whiteboard. And you can use the styluses to share with students this question coming from where, and the next is move to what kinds of conclusion. So it's good to show the interaction, but at the same time, we have complaints. Students say your video recorder always see your back head. Okay, why? Because I'm writing. Okay, so therefore, I tried a second approach. That is called transparent glasses. In fact, it's a glass. And a projection system will have all the lecture notes projected on the screen. And I'm a right-hander, but after recording, you see, I become left-handed. Okay, the advantage is looks like a student are in front of you. You are talking to the student, so this is one of the advantage. Okay, and I do the green screen as well. Okay, so easily you have your videos cropped from the original things. And you can have background like Egypt, pirate, the Greek wars like in industry 1.0. So all those background can become easily stitched. Okay. After this, then I noticed there are something because of my research. 2003 such time, right? So I have a granted project. Developing virtual reality for biological structure, and because of COVID, because of SARS, so we start looking into the protein structures, and then realize actually there are lots of helical structure, and helical structure is something often you found in the TM Park roller coaster. Therefore, I together with my student design a virtual reality game. You can actually follow the roller coaster inside the protein structure. That's SARS proteins. So Singapore Art Museum invited my team to set up an exhibition for 1 year public exhibition. Because of that public exhibition, MOE Science Center come to us, and I have been working with Science Center for many projects. Okay, like healing your seeing your healing, to visualize the interactive kinds of healing process, and virus, okay, and the genomics. So every year we work with Science Center to develop those virtual augmented reality kinds of exhibition. And even in China, we were invited to set up a demonstration in Beijing, the Chinese National Museum of Science Technology, and in Shanghai we did the same things. Okay, this indicate actually video kinds of lecture alone is good, but it's not good enough. Reason, there is no interaction. So the virtual reality exhibition actually is quite well responded. Therefore, my university discussed with us, see why not we develop some educational technology to introduce in the curriculum, introduce in the manufacturing. That's why we start this VARTeL, Virtual Augmented Reality technology-enhanced learnings. So in general, VAR or technology-enhanced learnings is trying to do something, teach less and learn more. This is the slogan from MOE, you know, the former Minister of Education highlight Singapore education reform. We will have to very much focus on teach less and learn more, all right? So to us, we try very hard to reduce the traditional lecture kinds of element. We do video recording, and the student is no more physically attend large kinds of lecture. Instead, they will use their own time, their own pace to video reading the kinds of lectures. And we have more time for interactive kinds of project, hands-on, okay, discussion, presentations, tutorials, and formative assessment. Okay, this is one of the lecture series called MLT. When I joined NTU, the first 2 years I used lecture to teach our manufacturing student on the manufacturing process. Very difficult to do lecture in this room. Almost like 1,000 students. Okay, somebody come late, leave earlier. You will see a lot kinds of issues. Okay, now we are doing something lecture digitally. For instance, we have instant food restaurant like McDonald's, like KFC's, like Starbucks. So students will sit there, enjoy coffee at the same time, watching the videos 1 time, 10 times, up to the student. All right, and we have also reused many of the area. Earlier it is corridor, now converted into self-learning space. And we have also student activity center designed to give students something like work hard, play hard, okay? And we have library, 24-hour open new version of library in the Hive. Students can actually study 24 hours a day in the new library, and they can have nets in the places as well. Okay, for specifically virtual augmented reality technology enhancement, what is exactly is this VARTeL? Okay, and to us, this is the education innovations. So we emphasize 4 elements. For instance, the learning space innovation. I have just mentioned this McDonald's, KFC, Starbucks area is actually 2-in-1 kinds of learning space. Marketplace, at the same time, it's a learning space. Okay, and we have also pedagogical innovation. I will touch a little bit further shortly. And we have educations, and we have also the content innovations. So these 4 elements require a lot of care. You need to think about innovatively and how our students can benefit from those kinds of innovations. And specifically, NTU come up a new building. It's called the Hive. Okay, it looks like a Chinese dim sum kinds of thing. So nickname is Din Jin Lou. Okay, and inside we have altogether 56 room. Only 1 room is something like this, staircase lecture theaters. The rest are all something like this, classroom designed round shape, circular shape. And there are 5-6 tables. Each table holds 5 students. So altogether this room is about 30 students can do their hands-on, their project discussions, their interactive immersive learnings. Okay. And so for educational technology innovations, I would like to share with you on these slides. I use a term called immersive and interactive learning environment. So it's a learning environment, no more only the so-called classroom. In fact, it includes hardware, software, content, pedagogy. These 4 elements are integrated in such a classroom, particularly in the Hive room. We have all the things well integrated. And for the hardware, of course, I just procure those parts from Harvey Normans, from some other places. But the integration is very, very important. It is not going to happen as you purchase a TV, it will become a VR, AR ready. No, you have to do a lot customizations. And the software part is mostly developed by my team. And we have also pedagogical kinds of innovation. I call it in-depth learning. Principally for VR, AR, or even AIs, you can use them to help our students better learning some of the topic, particularly those topics are very difficult. If a topic students have no problem, the lecture have no difficult, then forget about VR, AR, artificial intelligence. Traditional way is already proved, then you don't need to waste your time for AR, VR. Only when you think there are some difficult, students struggle when they want to understand how the chemical process develop, how the machining process is developed, then maybe there are chances. Okay, so I call in-depth learning. And for contents, this is very tedious. We have big team working over the last several years, create a lot of contents. Let me show you more of the detailed. In terms of technology, VR and AR, I call it virtual reality continuum. It's an entire spectrum. From one extreme is virtual world, another extreme is physical world. So in between you can have augmented reality, you can have mixed realities, all right? And my team actually focus on VR. We look at various different kinds of VR solutions. Some are very high end, some are lower end. And the tricky part, whether you can have your content 3D model create applicable to all different ends of VR. That's something difficult. And we also do a lot AR, but we focus on multi-modalities. For instance, we develop AR which can be locational based. Okay, suddenly you see a jet engine display in front of you. The location is related to this classroom. Okay, and we can have model based. A plastic model can become a trigger. Okay, and a book based. You can have a biological textbook, and the book will become alive into an AR book. And of course, many times we have notes, handwritten. We can turn the handwritten notes into AR kinds of content as well. Okay, so here is the summary. Some of the topics we have tried, like aerospace engineering, manufacturing engineering, petrochemical engineering, and automobile engineering, civil and construction engineering, as well as medical engineering, like medical instrumentations and device. Okay, let me show you videos. Hopefully the video will work. There is no sound. Okay, never mind, there is nothing too much. Okay, so this is a Hive. And you can see the classroom. It's a 14-based learning. And my students from year 1, year 2, year 3, year 4 all use this classroom for simulation-based, okay, hands-on based kinds of virtual experiment. This is a machining, and almost all the students, let's say, in year 2, they come to this virtual laboratory. Okay, play with turning machines, milling machines, and this is another experiment. It's F1, assembly of those parts. And the other one, this is all AR, augmented reality based kinds of jet engines for our aerospace engineering student. This is very important. Okay, and you can see, you can touch, you can interact, you can change a lot of parameters. Okay, and this is molecular cell biology, and even the so-called book-based or note-based kinds of AR work. This is model-based, is cell structures. Okay, we can turn all the physical kinds of elements become virtually available. Okay, so over the last several years, we have been developing the pedagogy, the content, the technology. Therefore, today, our student actually is able to do some of those in-depth learning in this particular classroom. And in fact, I have also helped many of the schools like Hwa Chung, Raffles, River Valley, and National Junior College to try this idea in different type of curriculum-based learning. Okay, and now you can take a close look on the VARTeL for machinings. And the physical machine we have, actually in my school we have 6 turning machines, another 6 milling machines. But you know, my intake, every year we take about 700 students. So if all the students going to do the hands-on, then you have a very long queues. And also, if you are going to do cutting or machinings, the raw material itself is not free. You have to budget these consumables times 500 students. So it's quite a large lump sum. And what we do, we just model, we create the same machines in the workshop with the dimension exactly the same. So create such a virtual machine, and the students are able to do the virtual hands-ons. Okay, and before these kinds of education innovations, our students actually virtually, majority of mechanical engineering students, they do not really have a chance to do the machinings. And what they do typically is we bring the student to the workshop, and we will invite our experienced technician to demonstrate how this machine works. Okay, only small percentage of mechanical engineering student at year 3 or year 4, then they start really doing the hands-on, physical hands-on. This means their specialization is manufacturing related. But every student now are able to try it virtually for machinings, just like a pilot. Before you actually have the physical flying the aircraft in the space, you can do it virtual or simulated kinds of training. Okay, same things for the aerospace engineering. The very sorry, I think it's moved too fast. The jet engines, we do have a jet engine in my school, but it's actually donated from Rolls-Royce. We have a very nice box and display somewhere in front of the aerospace laboratories. And the student, even you have this tangible kind of jet engine, there is no functions. You can't open, so it is only a toy. Okay, so from this point, we realize there is a good need to actually have a virtual versions. So we spent a lot of time to have a digital twin of this jet engine. Okay, and the same for the aircraft, for the F1. Particularly for F1, we do assemblies. You need to teach our students how assembly you can do step by step. Okay, and constructions. Okay, I myself from mechanical and aerospace engineering, but I do have quite a number of building and construction kinds of project work, particularly on the building information model, BIM. BIM to me is a digital version of the building, right? And we also have the crane simulated crane used. So students from civil engineering actually can try this idea to play with the construction process and also learning better about building information models. Okay, civil chemical engineering. We have chemical and biological engineering students, 300 students easily every year. But learning chemical process like a distillation is painful. Okay, partially we do not have a physical kind of plant. So what the school is doing, actually have a mini version called pilot plant. They have many of those tubes, and the experiment is very time consuming. Once you start the process, you have to wait, and maybe 1 hour, 2 hours later you see the result. And the most painful thing is even the chemical process is on the way. You do not really, you can't see inside. You see, everything is not transparent. So you have kinds of black box for this learning process. Okay, so I work with a colleague from School of Chemical Engineering as a research project. we simulate the process of distillations, including how we can model the numerically about the process and visualize them in virtual reality kind of environment. Today, students from chemical engineering, they visit the Hive lab to try the VR version. They also have AR versions. Each and everyone can use a smartphone or Android device to do it their homework. Okay, use the apps we developed. Okay, and the cell molecules, yes, similar things, and even physics like electromagnetism, because this is a very difficult part. Normally we can't really see what's inside the motors, whether the electromagnetic field can become something visible. That's a difficult part. And at the same time, if you have a circuit with the current on, then it will supposed to generate the force, and never you can really feel the force. Okay, so use VR and AR. Actually, we can make it visible and tangibles. Okay, and mathematics. Many students actually in the engineering mathematics side struggle. Reason being, mathematics is always abstract. Like this is one of the apps we developed. It's teaching students about vectors. You know, vector cross product, okay, dot product. It's quite abstract, okay, and now students actually can use this VR environment to really appreciate, to interact with a vector. You have vector 1, vector 2, how the third vector called cross product can generate it. Okay, so my provost was in the laboratory, by the way, he's a mathematician, try various of these math kinds of apps. Okay, let me now show you videos how we do. I hope this works. Okay, these are jet engines, quite complicated. Now the student can use their hand gesture to actually separate or disassemble the jet engines part by part. And importantly, they need to figure out the sequence called this assembly sequence. Which one remove first, second, okay? And in the realities, the jet engine is super complicated, very heavy. We need to use industry crane to separate them, right? So now in the Hive virtual environment, they can use their hand gesture to separate them and check their structure as well as their functions. Okay, maybe for the interest of time, I will skip to the next. This is the AR version. Earlier version is VR. For the AR version, student can install this app and bring home to play with the same jet engines. And you can see the structure actually is a locational based, superimposed on the physical jet engine. And but the advantage is you are able to see through and reach in the internal structures, and you can change parameter to simulate flow dynamics. You can actually have the physical kinds of jet engine function become available. In the gift donated by SQ and Rolls-Royce, there's no such functions, but now you can see you can play with many of different functions, use a virtual augmented reality technology. By the way, the model we created can be used both for AR and for VR. Okay, so this is one, the AR versions. And for F1s, we emphasize the engineering kind of parts. It's called assemblies, how you can assemble our engineering part. Typically we use SolidWorks, right? SolidWorks has a function called smart matings. If you have two parts, you want to stitch them together, there is a function. You need to identify age shared, and then you will have to identify two face first, then edge, then vertices. Okay, it is very different from the actual assembly process, like in the assembly line of car. And often we use robotic arm together with a hand workers kinds of manual approach. So we actually implemented this kinds of process for better learning about the assemblies. Okay, here I would emphasize the pedagogies, because virtual reality often we see Oculus, particularly there is a pictures, Facebook released a picture several years back. Mark is walking, behind him or next to him there are hundreds of people wear Oculus. Okay, all these people are in the virtual space, but there is no way you can have two of them communicate, right? Learning actually emphasizes interaction, communications. So we feel it is important to let people, students in the same learning team communicate to each other. So in this case, one is wear the Oculus, the other one is using the 3D kinds of movie, we call the polarizing glasses. So they are in the same VR space, but they are able to communicate. Okay, in fact, not only two person, we always have 5 students in the tables, and one student become a master player. Then the rest will start to talking to each other, see what's wrong, and what shall they do next. Okay, so they take turns. Each student can have time become a master players. Okay, so the team-based approach indeed through these kinds of pedagogies. Okay, not everyone have Oculus, otherwise they do not see each other, can't communicate each other. All right. Okay, now the scalabilities, and we developed the software in-house by our own team. Okay, and you can easily duplicate 1 set, 2 set. So the scalability in this case become much easier, not like a physical machine. If you purchase easily 100K for one CNC machines, for instance, and if you want to buy 2 and 3, then the budget itself will become a big issues. So the scalability using VR, AR actually is indeed, and as a loom, it's very well used by different year 1, year 2, year 3, and different school. Okay. Okay, and other school classroom activity, for instance, the same classroom used for debate, for presentations. This is one of the last session. Our students are form a team, each table 5 students, right? So they will argue whether virtual augmented reality or metaverse, they have pros and the cons. Then they will fight each other, see which is really kind of problem, how they can solve through these kinds of debate sessions. Okay, and the other last things I would like to highlight is a fun element. Because learning, we know it is should be a fun journeys. If it is very boring, then I think many of the students will not really learn well. So try the fun learning or inject the fun element in the learning process itself is super important. Okay, so in our case, for instance, I think students assemble their own F1 car. At the end of the day, they can simulate the racings, and this way, the entire learning kinds of process indeed have the fun element well integrated. Okay, for the curriculum modules, actually, last semesters are very busy. Okay, year 1 I teach computational literacy, teach students how to do coding, Python programming. Year 2 I have a module, it's called virtual augmented reality. It's introduction to year 2 student, and they will come to the lab doing some kinds of virtual hands-on. Year 3 is metaverse engineering. It's a project. Student will come 5 weeks doing a project. Okay, and year 4 I teach the module is called computer-aided engineering. Okay, and the student come and they use a facility doing tutorial doing hands-ons and also debate, like the one I mentioned. And we have also residential education program. NTU students now about 50% they stay in campus. So the university is promoting the residential education. Happen one or two of the whole interested in VR. We have these facilities there, so they come to this classroom in the evening time. Okay, last but not mini master. We now have many of those SkillsFuture supported programs. So mini master is one of such programs. The student come to the lab, and I share with them the kinds of enabling technology for Industry 4.0 robotics, okay, VR, AR, okay, artificial intelligence, okay, and saying all those technology, innovation, pedagogical, and actually there are some fundamental things we are working very hard. Many of my PhD students, they spend 4 years, 5 years developing algorithms, for instance, fidelity modeling and simulation. They will have to focus on how to produce a solution which use less polygon, much faster to create a render image, okay, very much realistic, and interaction is always important. The model complicated, then real-time become a challenge. Whether it is visualization or interaction, real-time is always kinds of important part. Okay, and at the bottom levels, then the student will have to learn mathematics, learn artificial intelligence, high performance computing, big data. Okay, okay. One last thing I think is relevant to this education technology innovation in NTU, but more emphasize on the assessment part. Okay, this is still ongoing research project, not fully developed. The idea is to actually, because VR AR now is implemented, okay, like a game, when you are playing game, you are aware how much you are performing, whether you are good enough or your skill set is not there. Okay, learning should be the same. Okay, particularly MOE is saying primary school, year 1, year 2 students are no more doing examination, right? If the student is not aware, whether the student, if the teacher is not aware the student is doing the right thing, that without examination can be quite dangerous. So here we are looking to something called skills assessment. The assessment is not asking students to do paper examinations. Rather, we develop something called in-process assessment. We will see whether the student is able to achieve step 1, step 2, step 3, okay, using the VR, AR kinds of approach. And once their experiment is done, and just like our examination is over, often students will come to you asking, why I have this A minus, what's wrong, right? Something we call debriefing. So the debriefing technology used VR, AR is possible. We can show you, oh, you have made this mistake here because you choose the wrong kinds of action or wrong kinds of combinations. Okay, so this part I think we need some time to further. Okay, currently we are developing some kinds of research based on our student feedback. For instance, we are interested to know whether this VR, AR kinds of things can improve our students' situational interest, whether we can improve students' self-efficacy and affordance. So here, this is something, the educational research, and we have a few weeks, always start from pre-test and post-test. And you can see here, because of the technology, the mean value actually is quite good already. For instance, for situational interest, we can check the student average now is about 4.12. This NTU we have 75 A minus, 80 you have A, 85 is A plus. So this is about 80 plus kinds of academic performance for the VR AR kinds of module. We have this initial preliminary result. Okay, I have also tried. We want to learn whether students really benefit from this VR AR technology. For instance, student cohesiveness. Okay, for instance, student involvement, for instance, student investigation, whether students through this VR AR environment, they are looking into something like principle and some kinds of research problem. Okay, and we will also look whether the design team-based learning indeed improves the student operations. And we also want to see whether this way can help differentiations. Different students, actually they have different things. Okay, and the other opposite way is equities. We want a student to play this type of VR AR solution. Not only one or two students very active. The rest of students are just passively observing. So all these questions actually we set and ask students to give feedback because the sample is quite large, 227. So at the moment we are quite happy, students are happy as well. And we think this will help us to move on to implement some of the topics, as I said, very difficult. And that's why we emphasize learning pedagogy, in this case called in-depth learnings. And I have published quite a number of things, many books by speakers to share some of those research. And if you are interested, you can visit us and let us know. And last, I'm actually organizing a conference this October. It's an international IEEE symposium on mixed reality and augmented reality. One of the parts we are interested is to promote metaverse. So if you are interested to join the international community, and October somewhere in Singapore we have a very big international community. Even the submission phase just over, we received almost like 500 papers. Okay, so I will stop here, and my university asked me to show these modules. This NTU, we have a PACE, it's a professional the continuing education program, and I have one module developed with the PACE. It's a short course, and the first will be conducted September 6th to 13th. Okay, after one more month, then we have a second repeating October 4th to 11th. It's virtual augmented reality in manufacturing. Okay, if you are interested, you can visit the website through the QR code. Actually, the SkillsFuture scheme is available. If you are Singaporean or PR, you can apply. And it is going to happen in the NTU Hive. Okay, hands-on will be there. I stop here. I would like to answer any question if you have. All right.
Doctor?
Yes?
Would you mind explaining what would be the synopsis for this short course? Because earlier you point out it's a 4-year program for your undergrad students. What about this 4-day program?
Okay, I mentioned about year 1, year 2, year 3, year 4. They all use the same classroom, they use the same technology, except the focus are different. For instance, year 2, the student will have to learn science, technology, engineering, maths, we call STEM education. So the experiment session we designed, there are science, there are biological science, there are engineering module like F1 assemblies, we have mathematics. So it's a short course, it's not the whole year, it's only 1 or 2 months, yeah, kinds. And these modules is a short course, and I think we will have a few afternoons to do it in the VR AR classroom in the Hive. So you will learn some basic fundamental of VR and AR, okay, and you will have chance to play with the VR system available. By using the VR system, you can learn something like in engineering, machining, okay, in aerospace engineering, assembly or disassembly, okay. And after that, then we will have some discussion. Let's say many of us from different industry background. Maybe your company is interested to turn into the physical kinds of workshop into a digital twin. Then we can actually discuss, see how best you can start with step 1, step 2, step 3 kinds of discussion, brainstorming. Yeah. Okay. Is that something question you are? Or you
Not
have,
exactly. I want to know more.
Mm-hmm.
You know, when you introduce this course, and I assume most of us would be adult learners.
Yeah.
So this is what we should be going for instead of signing up for a 4-year program. So
It's
more
not 4-year
relevant.
program.
So that the short course more relevant.
Yeah, I think.
And I'm asking what would be covered in a 2 days program like this.
Yeah, it's not a 4-year program. So,
Yeah, so
principally, I think
yes.
we will have a few hours to share the principle. What is virtual reality? VR got a lot important part. For instance, always I emphasize 2 keywords: immersion and interaction. So where comes with the immersions and how interaction can be implemented, right? And from there, then we will talk about visualization, modelings, interaction, and the interface, because your application is different from others. But the principle is the same. You need to come up with the 3D models, and you can design it, use SolidWorks, or you can using something reverse engineering. So modeling part is one of the fundamental kinds of elements you will learn. From there, then we will talk about what kinds of interaction is best for different type of applications. Some are using hand gesture, some are using facial expression, some are using eyeballs. Okay, so all these things will be discussed in the classroom, best representing the state of the art. But possible, you have to think about from your own interest. If my company is going to convert, let's say, a factory into a smart production line, what likely you should do step 1, step 2, step 3. Okay. Yes.
My question is related to the metaverse and how there's a lot of technology revolving around that. There's a lot of games being revolved around the metaverse. We've got the education sector. With all of these different things coming in the metaverse, like we've got Facebook turning to Meta, so many things. What do you think will metaverse, according to you, will metaverse look like, and what will the Web 3 version of the internet look like, according to you?
Yeah, very good questions. Actually, metaverse, everybody have their own metaverse. So researchers also, different people in com science, they focus on the metaverse. It's different from people from engineering background. So to me, I think there are some fundamental issues we need to share across the platform. And what is this? Whether you can actually easily to come up with your own metaverse. So for us, we stay in office, okay, in HDBs, whether you are easy to come up with your metaverse without spend day and night, maybe a few weeks or months to design the metaverse. So there are such things we call auto reconstructions, and use something like artificial intelligence. You can convert this room into 3-dimensional kinds of space, and from there then you can aid the avatars, you can aid many of those things of your interest. So somebody from social media, there are interested in communications, and avatar design from social media is different from engineering. We want our avatar serving as the workers. For instance, you have electronic car production line. So the avatar need to understand what is the principle, how you can quickly assemble such a F1 car or electronic cars. So these are different kinds of, I would say, the application domain. You come with your own interest, and therefore you learn the basic stuff to do the metaverse modeling. And at the end of the day, this will serve the purpose of your own interest, your company's interest. Okay, so for the metaverse, indeed, these few years, it's growing very, very fast. And I myself are doing a few different metaverse, building and construction. I work with industry, Sapanajurons, HDBs, JTCs. And I also working with hospital to create something we call Mediverse, medical metaverse, Mediverse. Okay, I work with school like Raffles Hwa Chong's and their interest is to create educational verse, and all the virus cell molecules can become interactively available, so that the teacher can use the cell membranes, maybe enzymes, to teach year 3 students on the biological kinds of process. So at this moment, I think the effort is far from matured, and individually, I believe it is more cost effective, and there are certain principle cross-platform. You can use, you can learn, you can use it.
But it looks like an integration of different types of applications.
It's interaction definitely is one of the major part. Yeah. Okay.
So just a question here, because I do see that in NTU, students has a lot of good opportunities to experience VR, AR from year 1 to year 4. So pretty much they are the consumers of this content. So are they equipped with the knowledge to develop the content? And so from an EdTech perspective, how do NTU actually kind of create all this content? Is it by professors, or you have a dedicated team of education technologies that helps to create this AR and VR or even metaverse content? And just out of curiosity.
It is a multiple level approach. I do have those PhD postdocs, they focus on the enabling technology, develop a new algorithm, can actually simplify the polygon model. Originally maybe 1 million, 10% of polygons still represent the same kinds of shape, okay, and the performance become very fast. So there are such people taking care of the fundamental design. But content is quite different. There are engineering content, there are social media content. So somebody needs to create the content. So in this case, I would say my master student and FYP student, many of them actually through initial trainings, a few months of training, and they become comfortable. And they will have to work as a team. Individual person is hard to create a very large, comprehensive kind of project. So we always group student, maybe 4 or 5 students doing a joint project work, and with supervision by professor and by those PhD postdoc, then they can achieve much better result. And importantly, for metaverse or VR, AR, scientific accuracy for the content is super important. It is not possible you design a game without considering the amino acid structure. Actually, it's different from the standard kinds of curriculum-based kinds of concept, right? So there are certain QE quality control involved, and if a team is experienced, and if the team has been doing the work for the last 5 years, it's different from you just started, resources are already there. We have been reused a lot such, for instance, the cell structure I developed. Nowadays we have been reused again and again for various of different cellular related modules. Okay. Are they? Okay, you have one more question.
Right now, which if you know any specific companies which are leading the metaverse or leading this environment?
Okay, I have absolutely answers. Reason being is Microsoft, Google, and Facebook, and the other company called NVIDIA. They are all promoting metaverse. Okay, and you know Facebook, they renamed as Meta, so they are very much in the social media side. Microsoft is developing HoloLens, a mixed reality solution for metaverse. Okay, and NVIDIA, because this is a company produce hardware and software, they are GPU, you know GPU, and actually now it's penetration to all the hardware platform computationally, right? And the company is also developing various of different algorithms. I happen to actually have been working with NVIDIA for many years, and we are in the process of developing a few different projects, from medical to education to engineering, and they have a lot of resources, and also their network is really worldwide. Specifically, they have platform developed. It's called Omniverse. Omniverse is the idea more close to my opinions. I do not only do social media. I hope to have many elements integrated. So Omniverse actually have robotics element, have AI element, virtual reality element, okay, blockchain element, and possible in the futures, individual company may use Omniverse to customize the certain elements to make your company become much more efficient. It's something like a digital twin solution, but it's specific for your company. All right. Okay. Okay.
Prof, I have two questions.
Yeah.
You show an example of student learning using VR and AR. So which one do they learn better?
Oh, okay.
The second question is, you classify VR into from lower end to very high end. How do you define this?
Okay. Yeah, VR, AR, both are important to us. I start with VR. 20 years back when I joined NTU, I'm quite lucky I have a space and also got some dollars to set up a VR lab. And the screen, 120 inch, okay. And often the lecture is given the kinds of demonstration. Students attending lectures see something, okay, so the interaction is there, but it's quite limited in the VR because the hardware is high end. Today, actually, Oculus is much lower end. Okay, still $500 you have to pay, right? So for AR, as long as you have smartphone, iPhones, you can have AR. So this is something beautiful. Until we do 2-in-1. In the classroom, we use a VR solution so that students actually have a much higher quality kinds of content, and they can also take turn to be the master player. I call it master player. But back home, they have their own Android device, smartphones, the same contents, except the quality reduced. You will have to simplify the polygon number. So in that case, students use their smartphone or iPhones, see the same content as revision, but the quality, keep in mind, is not equivalent to the VR solution. Okay, and as for the, what is the second question?
How do you classify VR from low quality to high quality?
Yeah, again the cost. VR often, I have a very expensive solution. It's a 320-degree circular VR. Means all the wall turn into screen. And I have 5 projectors. Each take care part of the screen. Then I do something called edge branding. And at the end of the day, you see the whole screen like seamlessly integrated. It costs almost like $1 million. Okay, and then school come to me like Huazhong. They are very much interested in the technology. When asking how much, then they are actually. So in the last 15 years, we spent a lot of time to simplify the VR hardware, make it similar kinds of setting but lower cost. Okay, and from 1 million to 100K, 10K. Now, actually, you can have a few $1,000 set up reasonably good kinds of VR quality. So I call high quality, low quality. The cheapest one is the goggle cardboard, a paper glasses. You have your smartphone insert, you can still do VR, and your eye will be very busy because the cursor, in this case, move your eyeball, it will become a cursor. So in such a situation, the low end and high end basically is a cost for the setup. As for the AR, we are interested in whether the student can just use a smartphone and turn the environment like a book, like a 3D, a plastic model into something learning kinds of contact. Yeah, so these are things I think equally important. You can have VR in classroom complementary with AR at home, maybe somewhere McDonald's, and they play with AR. Yeah.
Thank you.
Okay. I think we have overshot the. Yeah, if you are interested, you come NTU visit us in the Hive, and you can try it on your own, see whether this is something maybe your company is interested to move into these directions. So talk to my student, and other researchers, maybe you can find a better idea. All right. Okay. Thank you very much.
Thanks for the time.
All right.